In 12.1 Day 1, we're going to look at right triangle trig. You've done some of this before in geometry, so it should be pretty much a review. If you look at the picture right here, it says, by aligning a camera with the surface of the road, this flat-footed house along Baldwin Street in Dunedin, New Zealand, appears to be sinking into the ground at a lopsided fashion. Warm up. In the triangle below, actually it should be to the side, which side is opposite angle A? Label that side O. Which side is adjacent to angle A? Label that side A. And which side is the hypotenuse? Label that side H. So I'm going to circle angle A so I can see what angle I'm looking at. So here's angle A. The side opposite angle A would be CB. The side adjacent to A would be AB. And the hypotenuse is the longest side. Now the hypotenuse is always across from the 90, or the longest side. And if you notice, for angle A, there's two sides that are touching angle A, but the adjacent one is the one that's not the hypotenuse. So the hypotenuse will be the longest side, and the adjacent side will be the other side touching angle A. Similar triangles have the same angle, so we're going to look at similar triangles today and do an investigation. What is the true about the ratios of similar triangles? Draw a right triangle similar to the one at the right that has one angle that is 50 degrees and one that is 90. Label the sides and find the ratios. So in class we're going to do this. We're going to each draw a triangle of different side lengths that have a 50 degree and a 90 degree, and the other angle has to be 40 degrees since there's 180 degrees in a triangle. And we're going to compare the ratios. And in class we do this and we compare ratios with everyone else in class, and you'll find that even if the sides are different lengths, if the angles are the same, if they're similar, our ratios are the same. And so we can use that to define trig functions. Here's the acronym we can use to remember the ratios of the sides of any right triangle. SOHCAHTOA. Here's what it stands for, SOHCAHTOA. S stands for sine, and O and H stand for opposite and hypotenuse. So the sine of theta equals opposite over hypotenuse. So there's SO. For the ka, it's cosine. Cosine of theta, which is just an angle, equals adjacent over hypotenuse. And tangent of theta just describes the relationship opposite over adjacent. So if you can remember SOHCAHTOA, it tells you how to set up the fraction, and then you can solve. So here's the first example. Find the values of the trig ratios, the three trig ratios, reduced if possible. So first up, start with your angle, and how are your two sides related to the angle? So this is the adjacent side, because I know the side's the hypotenuse that's across from the 90. How can we solve for this missing side here, the opposite side? Well, it's a right triangle. You can use Pythagorean theorem. So let's do that first. We have 6 squared, and I'll call this side B. So 6 squared plus our other side B squared equals 10 squared. 6 squared is 36. Oh, 10 squared is 100. I can write that in. Use algebra to solve, so subtract 36 from each side. B squared is 64. To get rid of a squared, use square root. So that side right there, the opposite side, is 8. So I'm going to write that in. Oops, didn't want to do that. Okay, so here's the opposite side. It is 8. That's the opposite side. All right, the three trig functions, SOHCAHTOA. Let's do sine first. The sine of our angle equals the opposite side, which is 8, over the hypotenuse, which is 10. Cosine of theta is adjacent, which is 6, over the hypotenuse, which is 10. And tangent of theta is opposite, which is 8, over adjacent, which is 6. And we can actually reduce these. 8 over 10 is the same as 4 over 5. 6 over 10 is the same as 3 over 5. We divide each by 2. And 8 over 6 is the same as 4 over 3. Okay, so there's how you can set up your trig ratios. And today we're also going to look at how you can use trig to find missing sides. Here's the second example. A 10-foot ladder leans against the side of a house. The ladder makes an angle of 60 degrees with the ground. Let's see if I can grab my line tool. How far up the side of the house does the ladder reach? Okay, so here's my house. Here's the ladder. Here's the ground. It's 90. So first up, draw everything we know. We know this is a 60-degree angle. The ladder, okay, how far? It's a 10-foot ladder. And we want how far up the side of the house does it reach, so I'll call that H. Actually, no, I won't call it H, I'll call it B. All right, so notice in a right triangle, if you have two sides, you can use Pythagorean theorem. But here we only have one side, so Pythagorean theorem is out. If you remember your 30, 60, 90 triangles, you could use 30, 60, 90. But since this formula, the section is for trig, let's use trig and solve. So identify your two sides here. We have our opposite side. We have our hypotenuse. So which trig function has O and A? So if we take a look at sine, cosine, and tangent, O and H is sine. I said O and A, I meant O and H. So we're going to say sine of 60 degrees, our angle, equals the opposite side, which is B, over the hypotenuse, which is 10. And then you're going to cross multiply and solve. So if we cross multiply, we can put this over 1. We'll have B equals 10 sine of 60. Now you want to make sure you're in degree mode. I should have popped up my calculator sooner. Make sure you're in degree mode, not radian mode when you type this in, so I can show you how to do that. And you'll get your answer when you type in 10 sine of 60. So it'll take a minute to pop up. So while we wait for that to pop up, I'll go over example 3 with you. Let's see if it's, okay, here it is. Sometimes it takes a while, so I'll wait. Okay, so while we wait, let's do example 3 together, the last example. An airplane is taking off with an angle of inclination at 18 degrees. When it is 800 feet high, how far has it traveled? So this is my triangle. Here's the ground. It's a right triangle. So angle of inclination is your angle with the ground. 800 feet high, so the plane height is 800 feet high. How far has it traveled? So you want the hypotenuse here. And we have the opposite side. So again, opposite and hypotenuse, that's sine. Sine of 18 equals opposite, which is 800, over the hypotenuse. And again, we're going to cross multiply and solve. Okay, so let's cross multiply this one, and then we'll go back over how to type in your calculator. So this over 1. We have 800 equals H sine of 18. And let's divide each side by sine of 18, which is a number. I would put that in parentheses in our calculator. Okay, so let's go over how to type these in. Let's go back to this one right here. Pop this up. Okay, so first thing, make sure you're in degree mode. So to do that, go to the home page, go to your settings, document settings, and I'm in degree mode. If not, change it to degree mode. Okay, so let's just open a new document. All right, so we want to add a calculator page. We want to type in 10 sine of 60 for the first one. So 10, here's the trig button, there's sine of 60. Okay, so that ladder was 8.66 feet up the wall. And our last example here, when we cross multiply, we want to type in 800 divided by sine of 18. So we'll do 800 divided by, I would use parentheses, sine of 18. Okay, so the height of the airplane, 2,588.85 feet. Let's type that in. So height, oh, how far, not height, it should be the hypotenuse, how far has it traveled? 2,588.85 feet. All right, so there's just a quick review of how to use a trig ratio to solve for sides. In the next section, we'll look at how you solve for angles.